All right, guys, so we're going to continue on with our notes over multiplying two rational expressions together. So we're multiplying two rational expressions together. I think we got to this one, because I know it was either we got to this one, I got to it in some hours, I didn't get to it in others. So this is where we're starting. So we're multiplying two rational expressions together. Now, when we multiply fractions, we multiply numerator with numerator, denominator with denominator, the top with the top, bottom with the bottom. Now, our first probably instinctual thing to do here is, well, to distribute through, multiply out, and go from there. However, if we do this, the degree and the terms that we're going to have are going to get bigger, and then we're going to have to factor it to see what's in common. So instead of doing that and actually distributing through, our first main step, and the first thing we want to do is actually factor each one. Because when we factor, we get it to two sets of parentheses or multiple sets of parentheses being multiplied together. And when we multiply them, they're just going to all go together. So it's going to be easier to factor first, then multiply. So when we look at these here, these two rational expressions, 3x minus 3x squared, x squared plus 4x minus 5, x squared plus x minus 20, and 3x. I look for whichever one I can see the factors of first, because it's going to be helpful in finding the rest. Because if something's going to simplify, we need an in common on top and bottom, the same expression on top and bottom, so it kind of gives us hints at what the others are going to factor too. Now, out of all of them, 3x is one I notice first, because 3x is a single term. It's a monomial, yes? One term. There's nothing to factor out. It's only one term. So it's telling me that the 3x is factored. We don't have to do anything to it. It's just 3x. There's no factoring that we can do. So I'm going to put it down. Now, the next one I look at is greatest common factors. Is kind of a nice one. And on top, 3x minus 3x squared. They have a greatest common factor of what? 3 and x, because 3 and 3 is in common, yes? X and x squared have a common factor of x, so we can factor the 3x out of both. Now, if we factor 3x out of 3x, it's going to factor to 1. Anytime something factors out completely, it's going to reduce to 1. We're essentially dividing it out and moving that term to the front. Minus. Now, the 3 from 3x squared is going to factor out. And if we factor an x out of x squared, we just get x. So if I factor 3x out of 3x minus 3x squared, we get 3x times 1 minus x. Questions on this so far? Now, where we go from here, it really doesn't matter. If we go to the bottom one, x squared plus 4x minus 5, that's fine. Or x squared plus x minus 20. We're going to have to factor both of them. At this point, I would pick whichever one we can see the factors of first, or think it's going to be nicer to factor first. We want to do the top or bottom one? We can do the top. Now, x squared plus x minus 20, there is no greatest common factor. 20 does not have a variable, and x squared don't have a number in front of it other than 1, so there's nothing in common. Third term, the sign is negative, so the signs will be opposite. One's going to be positive, one is going to be negative. If the third term is negative, the signs are opposite. Which then leads us to the factors of the first and third term. Our factors of x squared, well, they have to be x and x, because x times x gives us x squared. There's no other factors for it. Factors of 20. 1 and 20, 2 and 10, 4 and 5. Which one of these do we want to try first? 4 and 5. Which one positive, which one negative? Yeah, positive 5, negative 4. And again, just like with factoring, we can check it off to the side and make sure we have the correct factors. X times negative 4 is negative 4x. 5 times x is positive 5x. And negative 4x plus 5x. So, all right. So we have a positive 1x. Okay. So, we got the correct factors. We get up to this point. Because we kind of see what's going on. Mainly, we've just factored 3 different expressions so far. Because we factored the top 2 and, well, 3x factored, quote unquote. Now, last expression we have to factor is x squared plus 4x minus 5. There is no greatest common factor between x squared, 4x, and 5. X squared has a 1 in front of it. 5 does not have a variable. The third term's sign is negative. If the third term is negative, the signs are opposite. One's going to be plus and one is going to be minus, yes? Now at this point here, we need to find the factors of the first and third terms. Now the factors of x squared are going to be what? X and x. Now the factors of 5 are 1 and 5, yes? Now we could put the 1 with the plus and have x plus 1 and x minus 5, or we can have x plus 5 and x minus 1. X plus 5 and x minus 1. Now again, we can use the other factors to figure this out, or help us, because again, if something's going to reduce, we have to have the same expression on top and bottom. Because with putting it as x plus 5 and x minus 1, we now have an x plus 5 on top and bottom. It will reduce, it will simplify out. And if we did check it, x times negative 1 would be negative x. Positive 5 times x would be positive 5x. Tell me that the middle term is positive 4x, which is what we wanted. Those are the correct set of factors. Questions on this so far? Now, the first thing we did was just factor each of the terms on top and bottom. Because if we have something that's in common on top and bottom, they will reduce to 1 and simplify out. So the 3 here, so it would be positive 3x. The x minus, or 1 minus x, we could rewrite it as negative x plus 1. Yes, I will get there. Yeah, because there is a thing to it. Yeah, no, I'm going to lead up to what that shows. Now, at this point here, we're going to multiply everything together. Now, parentheses, when we write them next to each other, it's understood that it is product. We're multiplying them together. So really, the top, we're going to move our greatest common factor, our monomial terms out front, and just really rewrite the other expressions next to each other, top with top. Because 5, or x plus 5 times x minus 4 is going to be multiplied with our 1 minus x and 3x, so it's really 3x times 1 minus x times x plus 5 times x minus 4. We good with that part there? Yes? Now the bottom, all right guys, focus in, focus in. We have x plus 5 times x minus 1 times our 3x. Really to keep our terms nice, or kind of keep things together, those monomial terms, those terms that don't have the plus or minus, I move them to the front of the expression, just so we can keep them together up front. And then write our expressions, our sets of parentheses after it. Now looking at this here, we get 3x times 1 minus x times x plus 5 times x minus 4 over 3x times x plus 5 and x minus 1. Well, x plus 5 over x plus 5 because it's a product, they simplify to 1, they simplify out. What else simplifies out? X minus 1 and 1 minus x looks like they should. The one on top, it's negative x, positive 1, and the one on bottom is positive x and negative 1. There might be something we need to do to get that to work out. Oh, we have what else in common? 3x and 3x. Now, the x minus 1 and 1 minus x, we do have the same two terms, but both signs are flipped, yes? So, if I factor, say, a negative 1 out, if I factor negative 1 out of this 1 minus x, if I factor a negative away from negative x, the x is going to become what? Positive, yes? And if I factor a negative away from the positive 1, it's going to become negative. If the terms, the two expressions, are the exact same, but the only difference is that the signs are completely flipped from one to the other, we can factor that negative out. It's going to flip the signs, and now they're the same. So now we can say that the x minus 1 over x minus 1 will cancel, leaving us with, we still have the negative and our x minus 4. Questions on this here? Now, part of what got you mixed up is how I wrote that, because I did actually write this one out on the note sheet I gave you, because I was just working some of them on my own. When we solve and factor, and we talked about this in the fall, we want the number in front of that variable with the biggest exponent to be positive, yes? Well, here we see that it is negative. So what we could have done, instead of factoring out 3x, we could have factored out negative 3x. Because by factoring out that negative, that x squared term, instead of going from negative 3x squared to negative x, it would have gone from negative 3x squared to positive x. So we already have it fixed, we already have it changed, instead of factoring it down and realizing, oh, the 1 minus x and x minus 1 looks like they could, so we need to fix the sign and go there. It kind of just, we do it from the start. Does that make sense? Kind of. Let's look at the next one here. Because here we can see in the top on the first one, we've got 5x minus 5x squared. There's a good chance, because that term with the biggest power on the top is negative, we're going to probably have to factor that negative out. So that we get the x to be positive, it's going to be nicer to work with. If that x squared, that variable with the biggest exponent, say, like this one here, is positive already, we don't have to worry about a sign change. We'll get to this one next. So if we look at this one here, because on top, 5x minus 5x squared, yes, 5 is in common with 5x and 5x squared. And we also have an x in common with x and x squared, yes? But that variable with the biggest exponent is negative, yes? We want it to be positive, because even if it was, say, cubic or higher degree, we want that variable with the biggest exponent. It's still going to be it, even after factoring out a greatest common factor, because it's going to have the biggest exponent. We still want it to be positive, so we'll pull that negative out to fix the signs. Because if I factor negative 5x out of negative 5x squared, well, that negative is not going to be a negative anymore. It's going to become a plus. And when I factor the 5x, 5 out of 5x squared, 5 is going to factor out. And when we factor an x out of x squared, we get x. When we factor that negative 5x out of negative 5x squared, it's going to become positive x. When we factor the negative 5x out of 5x, well, the 5x is going to become 1. But since it was positive to begin with, it's going to become negative. So really what we're doing is we're taking both of those terms and just dividing it by 5x, negative 5x, moving that negative 5x out front, and seeing what we get. Questions on this here? Now, if we're not sure we did it right, we can always check, because negative 5x times negative 1, negative and negative make a positive. 5x times 1 is positive 5x, yes? And that's what we started with, so we're good there. Negative 5x times positive x, the negative times the positive would make a negative. That's all we had. 5x times x would be 5x squared. So we can make sure in just signs that it's going to go back to where we were. We good with the first part? Well, we know that this has to be what? 5x. Why? It's a single term. There's no addition, subtraction. It's a what we call monomial, single terms. Nothing we can do with it. All right. X squared minus 4x plus 3. We want to factor it first, or x squared minus 5x plus 6. Doesn't really matter. Which has more factors, 3 or 6? 6. Let's do the one with 3. Because if there's less factors for the terms, the first and third term, there's less options for us to actually factor it too. So x squared minus 4x plus 3, since the third term is positive, the signs are the same and match the sign of the middle term. So negative and negative. Factors of x squared are x and x. We only got one choice. Factors of 3. 1 and 3. Again, only one choice. So x minus 1 times x minus 3 is the only way this factors, and if this doesn't work, it's not factorable. But we can check and make sure these are the correct factors. X times negative 3, negative 3x. Negative 1 times x is negative 3x. Negative 3x minus x, negative 3 minus 1 is indeed negative 4. Negative 4x, that is the middle term we wanted. So all that says is yes, these are the correct factors. Questions on what we've done so far? So now we just need to finish factoring the last one, yes? No greatest common factor. So we'll have 2 sets of parentheses with 3 spaces. The third term is positive. Scroll up just a little bit. Positive. So the signs are the same and match the sign of the middle term. So minus and minus. Factors of x squared are x and x. Now our factors of 6, 1 and 6, or 2 and 3. 2 and 3, because really that x minus 1 has already been taken care of on bottom. Because the one on top of it, negative 1 plus x, is just x minus 1. So those are going to simplify for sure. So if we want something else to simplify, it's going to be helpful to use 2 and 3. And if I check it, x times negative 3 would be negative 3x. Negative 2 times x would be negative 2x. And negative 3x minus 2x would indeed give us negative 5x. That's the middle term we want. We can go from there. Questions on this so far? So we have them all factored, yes? So we can multiply them together and simplify. Could we simplify at this point? Well, yes. If there's something in common on top and bottom, it's going to reduce, whether it's in 2 separate fractions being multiplied together or as one, yes? And the reason I say that is, well, these are the same, yes? So they would cancel out. Now, if we didn't see it, that's perfectly fine, because we fix it and say it's x minus 1 times our x minus 2 times x minus 3 all over 5x times x minus 1 times x minus 3. I think we feel good to get here. Yes? Biggest thing especially I would say is hopefully we kind of understand we're seeing the steps step by step. Not so much, again, I need to start saying this more, it's not so much about the numbers, the specific setup, but it's the process we go from A to B to C. As we're doing this, first step is just factoring. Once we get them all factored, multiply them together. Then we see what's in common on top and bottom. Now, x minus 1 is the same on top and bottom, so it's going to reduce out. What else is going to simplify? X minus 3 and x minus 3. Now the question is the negative 5x and 5x, would they simplify? They would, because the negative 5x, because it is, part of it is 5x, but really it's being multiplied by what? Negative 1. So sometimes we're used to, by this point, especially seeing it as negative 5x as one term, but it's really a negative 1 times 5x. So we can say that the 5x and 5x, because those are just the same, will cross out, but what do we have left over? The negative 1, yes, and the, so we still have the negative 1 and the x minus 2. Now if we wanted to multiply the negative back through, it'd be negative x minus 2. Or negative x plus 2. And that's it. So we can say negative 1 times x minus 2, or we can just write it as negative x minus 2. We don't have to have the 1. It's understood. Questions on this here? So we're starting to get to see the process with this here. Even though the numbers are changing or how it looks changes, first step's still the same. Factor the top and bottom of the fraction. Step 2, once we do that, multiply them together. Step 3, simplify. And I would always look at the numerators and denominators of each one to see which one I can see the factors at first, which one's going to simplify first. Because once we do that, it gives us a roadmap or hints at what the others are going to factor to or possibly factor to. Now, when I look at this one here, the second fraction, that second expression brings, I'm kind of more focused on it than the first one. Because if we look at the bottom of it, we have 2x squared. It's a term. There's no addition, subtraction. So it's just what? 2x squared. Because it's a single term, there's no 2x plus a number, 2x squared plus 4x. There's nothing we can factor out of both terms because there's only one. It's just 2x squared. If there's only one term, there's no addition, subtraction. It's just that term. There's nothing we can do to it. On top, we do have two terms. We have x and 3, yes? Is there something in common with x and 3? No. Is x to have an exponent? No, so it's a degree 1. There's nothing in common. There's nothing we can do to it. Just because we're factoring doesn't mean that everything will have to factor to 2 sets of parentheses or multiple parentheses. Because sometimes it is simplified as is. There's nothing we can do to it. Because by this point, especially when we're going over a concept, we've gotten, not trained, but kind of, to the point where everything, we're talking about factoring, everything has to factor. Everything has to do this. No, we set them up that way. I set them up that way so we can see it in all the spots. Doesn't have to be. Here, the second parenthesis is second fraction, top and bottom simplified as is. Don't have to do anything to it. Now we can look at the first one. We have 2x squared minus 10x and x squared minus 25. Which one do we want to look at first? The top. Is there a greatest common factor between 2x squared and 10x? 2x. Because if I factor 2x out of 2x squared, it's going to simplify to x. If I factor 2x out of 10x, x factors out. 10 is going to become 5, yes? Why would I not factor a negative 2x out? The variable with the biggest exponent is the x squared, yes? Is it negative? No, it's positive, yes? So there's no sign to change. There's nothing I have to fix. It's already going to be positive. The last one and the one before, the x squared term was negative. Because that x squared, that variable with the biggest exponent was negative, when I factored that greatest common factor out, I wanted to pull that negative with it to make it positive. Now we need to factor the denominator, x squared minus 25. We have only two terms being subtracted, yes? Hopefully it's a difference of perfect squares, and we know it is. If they're being subtracted, they are. And x squared is a number or term times itself. Well, x and 25 would be 5 and 5. So since it's a difference of perfect squares, it factors a squared minus b squared factors to a plus b times a minus b. Or in this case, x plus 5 times x minus 5. I would get very used to or kind of comfortable with difference of perfect squares because a lot of places like to use those, especially for these here. Questions on this so far? So first thing we had to do is factor. We did that, yes? Now we could simplify at this point x minus 5 over x minus 5. They're the same. They're in the same fraction. We can cancel them out. Or we can just go on and multiply. Our two sets of parentheses together. And yes, the x minus 5 and x minus 5 will cancel. They'll simplify out. They will become 1. 2x and 2x squared. Can we just say that they both cancel out completely? Well, no, right? Now, the 2 and 2 will cancel out because 2 divided by 2 is 1. It does simplify, yes? How many x's do we have on top? 1, because it's to the first power, yes? How many do we have on bottom? 2. So since we don't have the same amount, they can't just cross out because I don't have the same amount on top and bottom. But I know one of the ones on top will cancel with one of the ones on bottom, which will leave me with 1x on bottom, yes? So the one on top cancels out completely. And the one on bottom is just really going from the second power to the first. This is one way, especially as you see me write it here, how I kind of keep track of it. It does get a little messy, but we do see the one on top is gone. Or as we did yesterday, when we divide like bases, we subtract the exponents. So 2 minus 1 is 1. Since it's bigger on bottom, it stays on bottom. So we'll still have the x on bottom. And we'll still have the x plus 5. The only thing left on top is x plus 3. So it's going to become x plus 3 over x times x plus 5. Questions on this here? I'm not going to talk much about restrictions on this here because it's just what's going to make the denominator be 0. Questions on this here? We ready for the next one? Now there's two like this one here, 23, and I think the next one's 24, or whatever the number is. Now again, this looks like we've taken the difficulty and thrown it up a full few notches, yes? It's still the same thing. It's still the same process. It's not changing anything. Because again, the first thing we want to do is factor each of the 4 spots. Now the first numerator, c cubed plus 8, wouldn't necessarily be the first place that probably you'd start. But c cubed plus 8 is a sum of two cubes. Sum of two cubes is a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. That's just how it factors, our formula for sum of two cubes. And for us here on top, we would need to see what a and b are. A and b are the terms or numbers that times themselves 3 times, gives us x cubed and 8. Because for x cubed, it would be x, because x times itself 3 times is x cubed, and 2 times itself 3 times is 8. So we can do this pattern, a plus b, so it'd be c plus 2, times. Our next spot is a squared. Well, a is c, telling us that we get c squared, minus a times b. So a and b, so that'd be c and 2, plus b squared, and the value of b is, so we get this here, yes? Something looks interesting about that quadratic part, the bigger part, yes? Because the first one, c squared, that's fine. The middle, we have c times 2, which would be minus 2c, yes? And 2 squared is what? 4, yes? Don't we kind of have that up there already? The bottom of the second one is c squared minus 2c plus 4. Isn't that what that's going to simplify to? So if c squared minus 2c plus 4 factors, or whatever the factors of it are, aren't they going to still be the same as c squared minus 2c plus 4? Is there a reason to factor it? If they're already going to be the same on top and bottom, we might as well leave it alone and just say they're going to go away. So there's really no reason to mess with this here. The interesting thing is c squared minus 2c plus 4 doesn't factor. We talked about the sum and difference of two cubes. We said the quadratic, I said the quadratic part of that will never factor, which means that doesn't factor anyways. So even if it did, because these are going to be the same, there's no reason to. Because whatever they factor to will cancel out already. The only real reason we would need to factor it is if it asked us to find the restrictions. If it asked us to find those values of x that would make the denominator, or here make values of c that would make that denominator be 0. Then we would need to know what the factors are. But here, since they're already going to be the same, there's no reason to mess with it. We'll simplify that here in a second. Let's look at the denominator of the first one, c to the 5th minus 4c cubed. Is there a greatest common factor between those two terms? They do have c to the what? 3rd. Which is going to leave us with c squared minus 4. Now, even for me, I do not try to factor those two pieces together. I'm not going to try to factor the c cubed out and then try to factor c squared minus 4 all at once. That's a little bit too much to try to do all at the same time. It's easy to lose track of numbers, signs, and drop things there. So we'll just leave it there. On top, c to the 6th minus 4c to the 5th plus 4c cubed. Or 4c to the 4th, sorry, not cubed. Is their greatest common factor? Yes, it would be what? C to the 4th. And if we factor it out, we reduce all the c's by 4. C to the 6th becomes c squared. 4c to the 5th becomes 4c. And plus 4c to the 4th just becomes 4. Now we can rewrite and simplify the quadratic part of our sum of two cubes It's going to become c squared minus 2c plus 4. I'm going to look at the denominator first, c squared minus 4. We have two terms being subtracted, yes? C squared kind of gives us a hint it's a difference of perfect squares because it's c times c. What times itself is 4? 2, yes? So it would be what? C plus 2, c minus 2. Our sum difference of perfect squares are going to look the exact same, but the signs are opposite. On top, we still have the c to the fourth, but we do need to factor the c squared minus 4c plus 4. Since the third term is positive, the signs are the same and match the sign of the middle term. So they would be negative and negative, yes? What are the factors of c squared? So you can see that's the only choices we have, yes? Factors of 4, 1 and 4, or 2 and 2. 1 and 4 could work, maybe, possibly, but it definitely wouldn't help us with simplifying because most of the things we have on bottom are c plus 2 and c minus 2. So it'd be more helpful if it was c minus 2 and c minus 2. Now, we can check and make sure we get negative 4c. c times negative 2 is negative 2c. Negative 2 times c is negative 2c. And negative 2c minus 2c, lo and behold, is negative 4c, yes? Questions on this here? Okay. Now we need to multiply these together, yes? Would that do it? Because, I mean, for lack of a better term, just going, really just multiply them together, isn't it? I mean, when we rewrite it, all we're doing is just saying, zoom that out so I can move this to the top. I'm going to move c to the fourth to the front, and then just rewrite it as c plus 2 times c squared minus 2c plus 4 times c minus 2 times c minus 2. And yes, we could write it as c minus 2 squared since they're being multiplied by themselves. We can leave it as that there also. Now we just need to simplify, yes? Well, I will, as we already pointed out, c squared minus 2c plus 4 is going to be in common on top and bottom. Those are going to cancel out. What else do we have in common? C plus 2 and c plus 2. C minus 2 and c minus 2, yes? What else? Well, that's c to the third and c to the fourth. The 3 on bottom are going to be gone completely because they're going to simplify with 3 of the ones on top. And since there's 4 of them, we're going to only be left with 1 on top, yes? So what we're left with is c times c minus 2. Questions on this here? Would we say that the difficulty of that was way harder than the previous few? I mean, the steps we had to do more factoring, we had to do more steps. But I wouldn't say difficulty-wise, it was much harder than what we were doing. Would we agree with that? That problem did not come from the Algebra 2 textbook. I actually pulled that off a college algebra worksheet. That is the difference between Algebra 2 and college algebra. It's everything we do, except they take it a step further. Instead of just having 1 or 2 with greatest common factors, okay, we have higher degrees, we have a cubic. for the most part, it is the exact same thing. It's just that there was more steps to it. Okay. We'll have to finish this on Monday, and we will start the second part, or division. Not a whole lot of difference between this and dividing. A little longer than I thought, but